Welcome! Today I'm going to be talking about how to name ionic compounds in chemistry. In a few seconds, here's a summary of this video. So first, I'm going to be talking about how to name ionic compounds with a main group metal, and then I'm going to go through the steps to name ionic compounds with a transition metal, and then I'm going to do some practice problems, and I'm going to finally give you some practice so you can check your progress on this topic. Another note here is that the periodic table is linked in the description. If you're new here, my name is Liah, and on my channel you can find more science and math videos. We're going to start with naming ionic compounds with a main group metal. Now, how do you know that they are main group metals? Well, let's just take the shape of a periodic table. Okay, the metals in the taller parts of the periodic table, alright, are going to be your main group metals. The metals that are in the middle part are going to be your transition metals. So whenever we see a metal in the yellow areas, we know those are main group metals. And whenever we see a metal in the green area of the periodic table, we know that's a transition metal. Now, let's define ionic compounds. What are they? Well, these are simply going to be compounds made up of ions. Now remember, ions are charged particles. That means we have charged elements involved. All right, and when these charged elements come together, they're going to form an ionic compound. You can also say that ionic compounds contain a metal and a nonmetal. All right, so for these examples, we will see a metal and a nonmetal. On the left, we see some steps to name ionic compounds. So number one is to identify the elements. So we can say that this one, Na, is sodium. All you have to do is find the symbol Na on the periodic table, and you will know its name is sodium. And Cl stands for chlorine. All right, and the second step is to name it. Now I have in blue a little kind of formula on how to name ionic compounds with a main group metal. First, we're going to write the first element's name. So whatever comes first here. Okay, Na is listed first, then Cl is. So Na is the first element and chlorine is the second element here. So we're going to write the full name of the first element according to our little formula. So we're going to have sodium, and then we're going to have another word, and that's going to be the base name of the second element with the ending IDE. All right, now the second element is chlorine, and its base name is going to be chlor. All right, and that's going to have the ending IDE. So I'll add that, making this sodium chloride for the name of this formula. Let us do another example. So again, we have our steps. We need to identify the elements and then we need to name it. So first we're going to identify that we have Li and we have N. Li is lithium and N is nitrogen. Knowing the names of these elements, what do you think the name will be? All right, so we have the first element's name. So we're going to have lithium. And then we're going to have the base name of the second element plus the ending IDE. So what is this going to be? Well, we're going to have nitride. Okay, so IDE ending and the base name of nitrogen. All right, so when you see Li3N, you know its name is going to be called lithium nitride. And just to point out, right now when we are dealing with ionic compounds, this little subscript that tells us the number of lithium atoms we have does not matter in our name. We do not take that into account. So let's do another example. Here we have CaOH2. So we need to identify the elements here. But in this case, we're going to see that we have calcium, and this OH part is actually a polyatomic ion, aka a common ion, which we need to know the name of. And so we're going to have calcium as the first part, and the second part, the OH part, is called hydroxide. All right, so when you have a common ion, you're going to use the name of that common ion and not of the individual elements in that common ion. Now, what's going to happen here? Well, we're still going to have the first name. So we're going to have calcium. Now, what's going to happen for hydroxide? How are we going to add that into the name? Well, this rule actually changes. When we have a polyatomic ion as the second part of our formula, chemical formula over here, we actually just use the common ion's name. And that common ion in this case is called hydroxide. And so we're just going to put that over here. And so CaOH2 will be called calcium hydroxide. Now we're going to talk about naming ionic compounds with a transition metal. So how is that done? Well, as you see here in this little formula, the process is very similar, except that we need to add this part in red. In parentheses, we're going to have the metals charge, meaning the transition metals charge, in parentheses, written in Roman numerals, okay? So we're going to identify the metal and the non-metal, we're going to identify the elements, and we're going to name it. Okay, so in this part we have Fe and we have O. Fe is iron, O is oxygen. Now what does this formula say? We're going to have the first element's name, alright, so we're going to have iron. Then in parentheses we're going to have iron's charge. And finally we're going to have the base name of the second element with the ending IDE. And so we're going to have oxide for the end. Okay, so if oxygen has the base name of ox and the ending IDE. Now we need to find iron's charge. Now because iron is a transition metal, its charge varies. That's why we need to specify it. Alright, and so we're going to find iron's charge based on the charge of the element it's paired with, so oxygen's charge. Okay, because in total, the entire compound needs to have a neutral charge. Okay, so we'll start writing a little formula here. Total is 0 charge, and we have here an oxygen that has a -2 charge based on the ionic charges on the periodic table. And we know that -2 plus something needs to equal 0. And we know that x will be 2, okay, because -2 plus +2 will be 0. Okay, so that means that iron has a +2 charge, meaning we need to write this in Roman numerals. And so the way you would call FeO is iron to oxide. Again, to recap, we need to specify the transition metals charge because transition metals have a variable charge. They can change, and that's why we need to specify them, okay? We need to tell the reader what charge that transition metal has. And we're going to find that based on the charge of the entire compound and the charge of the non-metal. Let us try to name another ionic compound with a transition metal. Here we have V2S3. Okay, so V stands for vanadium, and S is for sulfur. All right, so we have identified the elements, and we know that vanadium is going to be our metal, or our transition metal, and sulfur will be the non-metal. Now we need to use this little formula here in order to name this compound. So we're going to name it by using the first element's full name, so that's going to be vanadium. It comes first here listed. Sulfur is our second element, and then we're going to have the charge of vanadium in parentheses, and then finally we will have the base name of sulfur plus the ending IDE. So we're going to have sulfide, okay, IDE ending, and the base name of sulfur. Now we need to find vanadium's charge. Now let's ask ourselves, what is the entire charge of this compound? Well, we see no charge up here, right? And so we know that the entire charge is going to be 0 in total. And we know that there are 3 sulfurs. Now sulfur has a -2 charge, and there are 3 of them. So we do 3 times -2. Okay, this is going to be -6. So basically we know that 0 in total is going to be equal to -6 plus something. So what is that number? Well, it's going to be +6. All right, and so what's missing is a +6. Now because there are 2 vanadiums, okay, 2 vanadiums, okay, so we'll put a V here and a V here, they're going to split the charge evenly. We're going to do 6 divided by 2 because there's 2 vanadiums, and that will be +3. So each vanadium will have a +3 charge, and that is the charge we will put in parentheses, the charge of an individual vanadium atom. So in naming ionic compounds with a transition metal, you do need to pay attention to these little subscripts, because you need to find the charge of the transition metal. So in the end, V2S3 will be called vanadium 3 sulfide. Now let's do one last example. Now we have Ag2 and CO3. We need to identify the elements. Ag is silver, and CO3 is another common ion called carbonate. The thing to know about carbonate is that it has a -2 charge. Right, now we have identified the metal and the nonmetal. Obviously, silver is a metal. Carbonate will be our nonmetal. Now, silver, even though it is in that middle part of the periodic table, has a standard charge of +1. So what is going to be the name of this compound? Well, we're going to start out with the first element's full name, which is silver. But over here, we're actually going to eliminate this part, okay? And this part about the second element, because we have a common ion, we're just going to put the common ion's name. Why did I eliminate this part about putting the charge for silver? I did that because we know silver is +1. It doesn't vary in charge. So even though it is in that middle part of the periodic table, it is an exception that you should be on the watch for. All right, and so we will not put silver's charge and instead name this as we did for the ionic compounds with the main group metal, which was to write the full name of the first element plus the common ion's name. So we're going to have silver carbonate. Alright, so now it's time to check your progress on this topic. And please feel free to write the answer in the comments. So first, you're going to identify the rule that you will use to name each of these compounds, and then you will actually write the name of them. Thank you so much for watching, and if you found this video helpful, subscribe and like this video. I will see you next time.